here we are given a function, so this one is in the general form. So in part A, it says that using the method of completing the square, express this function into the vertex form, which is what we need to do, right? Because general form, if you want to change to vertex form, we need to use this completing the square method. So for this method, we have three main steps. So the first step is factorize. Factorize the value of x squared, which is -2, because we want the x squared value to be just 1. Right? So the -2 we need to factorize from values which have x. So this one and this one as well. Right? So when you factorize, you will have this result. Then the second step is to add the special value, which is from the x value, which is 2, we need to divide by 2 and then square. Right? And then this same thing, we need to put it at the back. It's just that we need to put minus here. Then the last step here is combine those values that have square. For example, the x and also this 2 divided by 2, which is 1. Okay, so these three things will become the green color part. And this one we just simplify to get -1. Right? Then later on we just multiply this -2 back to the things in the bracket. Then this will be your vertex form of this function. And for part B, we need to draw the graph of this function, but take note, this one they are given us the range, which is we need to draw this graph from -3 until 2. Alright, so let's go through the main 5 steps of drawing a graph. So for the first step is to check the value of A. So here our value of A is negative. So this means for the second step, to draw the smooth parabola, we need to draw the set face parabola. Third step, we need to find the maximum point. So we need to use the vertex form of the function, which we have done in part A. Alright, and then we just extract the values to form the maximum point. So take note, for the x coordinate, positive must change to negative. Alright, and then we can just plot the maximum point here. Then our fourth step is to find the intercepts. So x-intercept, we just change the y or the f of x to 0. Okay, but here, if you plug these three values into the calculator, the answer will give you either a decimal or there's a square root inside. Okay, so this kind of case, we cannot directly just write our answers for the next line. What we need to do is use the quadratic formula. Negative b, so b is -4, plus minus square root b square -4a, which is this value, c, which is 5, and then divide by 2a. Alright, so using the quadratic formula and then simplify a bit, you'll get this one. And then since it's plus and minus, let's split the answers into two forms. One is positive, one is negative, and then you can find your x-intercepts. And now we just put these two coordinates into this graph. But here we need to monitor the x-coordinate of the maximum point. So this value is less than -1. This one is more than -1. So -2.871, we'll put it on the left. The other one, put it on the right. And for y-intercept, we just sub x equals to 0, or you can just directly take the value from here, which is 5. Because this one is the general form and this part is c. C represents y-intercept. So our y-intercept would be 5. So if you want to plug this coordinate here, if you see the value of x equals to 0 is somewhere closer to this value, so I'll just put my 5 here. Okay, but before we go to the fifth step, remember we have a condition, which the graph must be drawn from -3 until 2. So let's find out the coordinates of the starting and ending points first, right? So if you want to find that, we can just sub -3 and 2 inside one of these functions lah. But this one I chose the vertex form. Okay, so by plugging in, then you will get your starting point is -3, -1. So if you look at the x coordinate, it's actually very close to this x-intercept. So for the graph here, let me rub off a bit. Okay, then I plug my starting point here. Then for the ending point, which is 2 and negative 11, this value's y coordinate is 0 and the ending point is 11, so a very big gap. So I'll draw my endpoint somewhere below here. Right? Then later on we can go to our fifth step, which is to draw our axes, and I'll label my x-intercepts and the y-intercepts and the endpoints. And the last part of the question, we need to state the equation of axis of symmetry if the graph reflects on the y-axis. So if we use this axis as the mirror and the black line as the object, our image will look something like this. So currently, our axis of symmetry is x equals to -1. -1 because this is the x coordinate of the maximum point. So when it comes to questions which involves reflection, right, usually the way of answering is, if the original value is positive, we change it to negative. If it's negative, we change it to positive. So for our case, the axis of symmetry's value is negative. So we just change it to the positive value. So our new axis of symmetry would be x equals to 1. Make sure you write x equals to 1, not just 1 only, because axis of symmetry is a line. So the line equation must have a x equal in front.